This is part 2 to our image analysis guidelines on chest and abdomen. Let's continue with our lateral chest practice analysis. As you can see on this image, we're not demonstrating the lung fields on a full inspiration. That is easily depicted by looking at the exaggerated cephalic bow. You also cannot count 10 thoracic vertebra ribs clearly demonstrated. So therefore, we want to bring the patient and let them know that we need to get their projection performed on the second full inspiration. This last practice analysis I thought was something that we should review. When looking at this image, you can see that both the diaphragms are not actually superimposed. The first thing I would actually do is refer back to my PA or AP projection to see if there is a height difference from the right and left hemodiaphragm. Or there may be something pathological going on, but I would check that prior to repeating the image. Also, maybe the patient might have some shift in their hips. So make sure that you take a look at the patient as a whole and review imaging prior to taking a repeat image. So let's move on to the AP chest projection, supine or mobile. Image analysis guidelines for the AP chest projections state that the lung field should be demonstrated symmetrical. Distances from the vertebral column to the sternoclavicular end should be seen as demonstrated as equal. The lengths of the right and left corresponding posterior ribs are equal. The chest should be demonstrated without foreshortening. The manubrium should superimpose the fourth thoracic vertebra. 1 inch of the apical lung field should be demonstrated above the clavicles. Posterior ribs are demonstrated with a superior bowed contour. The mandible should not be demonstrated within the exposure field. The clavicles should be demonstrated on the same horizontal plane. The scapula should be demonstrated or located and demonstrated outside of the lung field when possible. Both lungs from the apices to the costophrenic angles should be included within the exposure field. 10 posterior ribs should be visualized above the diaphragm. I have included the image analysis guidelines that we just reviewed. Let's take a look at our image analysis practice. In this image analysis, you can see that the apices are demonstrated more than an inch above the clavicles. So in this situation, we don't have so much tilt as a central ray angulation problem. Also, the diaphragms are demonstrated superior to the 9th posterior rib. Therefore, this projection was taken not on full inspiration. To correct this, we need to ensure that our central ray is aligned perpendicular to the mid-coronal plane. Also, we want to make sure we're taking that projection on the second full inspiration. In this AP mobile chest projection image analysis, we can see that the clavicles are demonstrated within our apices. We can also see that there is a horizontal contour of the ribs. Also, the manubrium is demonstrated above the fourth thoracic vertebra. we have again here a central ray angulation problem. In order to correct this, we need to adjust the central ray angulation caudally until it is angled perpendicular or aligned perpendicular, I'm sorry, with the IR. The central ray here was angled too cephalically. In this next practice analysis of a mobile chest, we have again some angulation problems. We can see that there is 1 inch of the apices demonstrated superior to the clavicles. The posterior rib contour is demonstrated as vertical. Also, you can see that the manubrium is inferior to the fourth thoracic vertebra. Therefore, the central ray is angled too caudally. Also, the patient's shoulders are raised up. You can see this because the lateral clavicular ends are superior to the medial clavicular ends. They're not lying horizontally in the same plane. So to correct all this, we need to adjust that central ray angulation cephalically until it's aligned perpendicular with the IR and depress those shoulders down to get those clavicles horizontal. So let's look at our final practice analysis of a portable chest x-ray. The first eyesore for me are all these external artifacts. If we can remove them or move them out of the lung fields, that would improve our image quality. Also, when looking at this image, you can see there is a elongation of the ribs of the right side. Also, you can see that the sternoclavicular ends here are not equidistant. So there's some rotation here. We also can see that the apices are demonstrated more than 1 inch above the clavicles. So we have rotation, we got artifacts, and we've got angulation issues. So we need to correct this. How we're going to correct this? Well, our central ray is angled too caudally, so we're going to adjust that central ray cephalically until that central ray is perpendicular with the IR. We're also going to, this patient is in a RPO position, so we need to bring that mid-coronal plane so that it is parallel with the IR. And again, we're going to remove or shift any of those artifacts that are covering the lung fields. Moving forward, I wanted to take a look at the right or left lateral decubitus chest projections. Generally speaking, the same PA image analysis guidelines and the AP image analysis guidelines pertain to a decubitus position. You just want to make sure there's no rotation or angulation issues. Biggest thing with decubitus positions is making sure that the patient is in a true left lateral or right lateral decubitus position without rotation. Let's look at this one practice analysis of the left lateral decubitus position. When looking at this image, you can see that one side of the ribs are elongated, which is this right side right here, and one is foreshortened. Therefore, we have some rotation issues. Your sternoclavicular ends aren't equidistant as well. The right side is situated further away from the left. Therefore, the right side of the thorax is rotated away from the IR in this PA projection. In order to correct this image or positioning error, we need to rotate that patient's right side toward the IR until that mid-coronal plane is aligned parallel with the IR.